Hello and welcome to Chapter 2, Section 2. Today is all about solving one-step equations. So these things can be pretty easy. If we just take it step by step, we can figure these out. So we've worked on translating sentences into equations, and we've worked on solving equations in a couple different ways. Now we're going to use some specific properties of addition, subtraction, multiplication, and division. And using those properties, we can solve any number of one-step equations, as we're going to see today. So we're going to work on solving equations. We'll hear the term equivalent equations. That just means the same. So these vocab words will come up in the problems that we'll focus on today. So we've also got this down for today's notes. The addition property of equality just tells us if we add the same thing to both sides of our equation, it's still a true statement. So we can add anything to both sides as long as it is the same. So as we see here, 14 plus 3 gives us 17. If I add 3 to the right side, I still get 17. So this will always be a true statement if you're adding the same amount to both sides. So we can apply that into problems. So all the example 1 problems we're going to do will be using the addition property of equality. So 1a tells us to solve this equation here. We need to find a way to get h by itself, and then we can check our solution to see if we get the right thing. So these are supposed to be one-step equations. So in one step, we can get h by itself. If this negative 12 is tied to this h by subtraction, we have to do the opposite of subtraction to get rid of it. So we will add to both sides. What will we add? Well, we'll add what will cancel out a negative 12. In this case, that would be a positive 12. So we take our original equation. We add 12 to both sides. And if we look here, now we have a negative 12 and a positive 12. These will cancel each other out on the left. So we'll just have h. And on the right, negative 27 plus 12. If you practice your integers, that is a negative 15. So h is a negative 15. That's example 1a. One step and we've solved that equation. That's addition property of equality. We could check to see that negative 15 is a solution if we go back and substitute in a negative 15. So this is what we said h is supposed to be. So if we go back to the original equation, if we plug in that negative 15 here, this whole thing must be a true statement. So let's see. If we put a negative 15, is negative 15 minus 12 negative 27? Well, yes it is. That checks out. So we know that our solution is correct. So it's a very good practice to do and when you're doing homework, on quizzes, and especially on tests. You can make sure that you're getting the right solution. So 1b, we need to solve this problem here. We can use the addition property of equality. So what can we add to both sides to get a by itself? Well, we see a negative 24 on the same side as our variable. We want to get that alone, the variable alone, so we need to add 24 to both sides to cancel this out. So we would get a on the left, on the right. If we add 24 to both sides, we will get a on the left. On the right, we'll get 24 plus 16. And we know 24 plus 16 comes out to a nice neat number. It is 40. So a equals 40. It is positive, so it should be letter choice A for this example. One step and we solved it. And there we have it. 1b, our solution is 40. Now we also have the subtraction property of equality. So just like with addition, we can subtract the same thing from both sides of an equation and it will still be a true statement. So we can see that in a couple examples. So 2a, we can solve by subtracting. We see our variable here is c. We want to get it alone. We see this is some addition here. So to get rid of this 102, we have to do the opposite of addition, so we'll subtract. What will we subtract? Well, the number that will cancel this out is a negative 102. So we'll subtract 102 from both sides of our equation, and then we'll check to see if it's right. So first, we take our original equation. Now we subtract 102 from both sides. On the left side, we will get just c And on the right side we get, if you remember integers, 36 minus 102 would be a negative number. The difference there is 66. So C should be a negative 66. Now if that's our solution, we can go through now and check to see if we plug in that value, is it a true statement? So if we substitute in, is negative 66 plus 102, does that equal 36? Is that true? And we see that yes it is. So our solution checks out. We've done this perfectly and we know our answer is valid. Now 2b, we have our variable k on the left side and it's tied with addition to a number 129. We can get k alone by subtracting away the 129 that we don't want. So if we subtract away 129 here, we'll just be left with k. So we have k on the left. On the right, we're going to get, remember we subtracted 129 from both sides. So we'll have negative 129 minus 42. You could also write this as negative 42 minus 129. It's the same either way. So k would equal whatever we get with these integers here. So if I have a negative 129, and now I'm going to take away 42 more. So if you remember on a number line, you have on a number line, positive numbers are going to the right. As we move to the left, we get more negative. If I already have a negative 129, so imagine this is 0. If I already have a negative 129, so I'm to the left of 0, and now I'm going to take away 42 more. That means I'm going to keep moving to the left 42 more. Our answer should be a bigger negative number. So what we should get here is something, a bigger negative number than negative 129. And if we look at our answers, 87 is positive, 171 is positive, 87 is a smaller negative number, so that's not right. So we know our answer should be a negative 171. That's what you get here with these two negative numbers when you bring them together. So double check that. Our solution is negative 171. There we have it for 2b. We used the subtraction property of equality to solve it. Now we also have multiplication property of equality, which tells us we can multiply the same thing to both sides and it will still be true. Division property of equality tells us the same thing. We can divide the same number to both sides of our equation and it will be a true statement. Of course, you can never divide by 0, so that's the only caveat there. We can never divide by 0, we can divide by anything else. Okay? So we can solve some problems by multiplying or dividing. So here we see our variable is k. It's tied by multiplication to this negative number here. So we need to get rid of this whole thing. The easiest way to get rid of this number, since it's tied by multiplication, is to do the opposite, which is division. So we got to divide away this number. So first we'll start with our original equation. We want to rewrite this fraction. This is an improper fraction. It's a mixed number. So we want to rewrite this mixed number as an improper fraction. So this is something much easier to deal with. Now we can divide both sides by negative 11 over 8. We'll get k by itself and we'll get a value over here. That will be our solution. So there's two ways you could solve this problem. You could divide by negative 11 over 8, or you could multiply by the reciprocal. So you notice if you multiply by the reciprocal, the 8s would cancel out. The 8s would cancel out, leaving you with 1. The 11s here would cancel out, leaving you with 1. And the negative signs would cancel out, so you would just have 1k, or just k. On the left. On the right, you would get a value. Okay, we're going to get a value for this whole expression here. Knowing that when you multiply fractions, you can just multiply straight across. So on the top, you would get 16. On the bottom, you would get 33. And we keep the negative sign, so it will be a negative 16 over 33. So there's our solution for that one. If you look at the steps again, we can either divide by negative 11 over 8 or multiply by the reciprocal. It's mathematically doing the same thing. So whatever feels comfortable to you would work for that problem. There's our solution as we move forward. So 3b, our variable this time is the letter b. We want to get it alone. It's tied by multiplication to a negative 15. So whatever our variable is tied to something else with, we always have to do the opposite. So this is tied by multiplication. The opposite of multiplication is going to be division. So we're going to want to divide both sides by that negative 15. If we do that on the right side, our 15s will cancel out. We'll be left with just b. Over here we're going to get a number, and it's going to be a nice, neat whole number. So on the left, if you try this in the calculator, negative 75 divided by negative 15 is just positive 5. Negative divided by negative gives you a positive. We already said we only have b left on the right, so we should have b equals 5. Now you can go back and plug in to check. So if is 5 times a negative 15, negative 75. And it is. So our answer for 3b, b is 5. That is the only value that will work for our variable to make this equation true. One step. Now 3c, in one step we can get m by itself. So here I see this is tied by multiplication, so I know I'm going to need to divide. But before I do any division, to make this whole problem easier for myself, I'm going to have to rewrite these fractions. Okay, this is written and this is written in such a way as a mixed number that we can't do any division, meaningful division when the number is written this way. We need to rewrite it as an improper fraction. So if you remember how to do that, we multiply the denominator by the whole number, and then we add what's in the numerator. That tells us how many thirds make up 4 and 1/3. So 3 times 4 we know is 12. 12 plus 1 is 13. So that written as an improper fraction, we would get 13 over 3 times m equals. Now on the right side we're going to do the same thing. So we know 7 times 5 is 35 plus 3. 7 times 5 is 35 plus 3 is 38. So we would have 38 over 7 on the right. So now we know we need to get m by itself. So two things we could do here. We can either divide both sides by 13 over 3, or we can multiply both sides by the reciprocal of this thing. So the reciprocal of 13 over 3 is 3 over 13. And 3 over 13 works because it'll cancel out our numbers here. So if we multiply across, 3 and 3, they cancel out. 13 and 13 cancel out. And on the right side here, we're going to get a value. So remembering we have to do the same thing to both sides. So we have just m left on the left. And on the right side here, we're going to get a number. So if I want to rewrite this, I know 38 times 3, what's that going to give me? 38 times 3. I know 8 times 3 is 24. 3 times 3 is 9, plus 2 is 11. So on top, we're going to get 114. On the bottom, we're going to get 91. And this can be simplified. So what do I have here in terms of whole numbers? Well, I have 1. And how many more extra do I have over 91? Looks like I have 23. So it looks to me like our solution should be letter choice A if I did all those steps correctly. And yes, it is. So that is our solution for 3C. M has to be that value. That's the only number that works. So 3D in one step, we can solve for C. We know the C and the negative 14 are tied by multiplication. So in one step, we're going to divide away that negative 14. What we do to one side, we have to do to the other side. So on the left side, we're going to do the same thing. On the right, this cancels out, so we just get C. On the left side, we're going to get a value, 32 divided by 14. That's not going to be a whole number. It should be a fraction. And it should be negative. So the only option that works in this case has to be D, negative 2 and 2/7. So sometimes with these problems, you don't necessarily have to follow through every step to get the right answer, especially with multiple choice. Sometimes they give you answers that just don't make any sense. So looking at this right away, I knew these positive numbers can't work because the answer has to be negative. So sometimes you can help yourself just by paying attention to the answers and seeing what could be right and what could be wrong. So we have a real world example to talk about. Looking at this one, it's about travel. So Ricardo's driving 780 miles to Memphis. He drove about 3/5 of the distance on the first day. We want to know how many miles did he drive. For some reason, my 3/5 is in the wrong place. So let me just rewrite that for us. He drove 3/5 of the distance, and the total distance is 780. We want to know how many miles did he drive then if he drove 3/5 of the way. So if we write these words as variables, we can figure it out. So if we use m to be our variable for miles, our equation must be our 3/5 number times the total number of miles will give us what that m value is, the total miles that he drove. So in words, we said 3/5 times the total distance is the miles he's driven. We know is means equals. Miles is m, we don't know. 3/5 is just a number. Times means multiply. And our total distance is 780. So we replace all of that. We get this here. And then in one step, we can solve for m. So 3/5 times 780 will give us a value. 3/5 times 780. If we rewrite that, we would get this expression here. And if we divide everything away, x would be 468. So how many miles has he driven? Well, Ricardo drove about 468 miles on the first day. Okay, our last example for today is another real-world context problem. We see water flowing through a hose at a rate of 5 gallons per minute. We want to know how many hours will it take to fill a 2,400-gallon swimming pool. So, given that this 2,400, let's circle what's important. 2,400 gallons is the total volume of the swimming pool. The water is filling the pool at 5 gallons per minute. So 5 gallons each minute. We want to know how many hours will it take to fill that 2,400-gallon pool. So the total amount of minutes, m, will be equal to our total 2,400. 2,400, I'll use G for gallons, divided by the 5, and this is gallons per minute. Now, as a side note, before we solve our problem here, we can always check the units to know what needs to go where, because we need to get minutes out as our units in order to make sure we're getting the right thing. So gallons divided by gallons per minute, let's double check that those units check out. So gallons divided by gallons per minute is what I've written there. We need to get just minute out as units. So let's rewrite this. So gallons divided by gallons per minute. Anytime you're dividing by a fraction, you can keep, change, flip. So keep the first thing, change the division to multiplication, and flip our last fraction. You probably heard that before. So this is the same as gallons times. We'll change the sign, keep change, and we'll flip this last one. So this is the same thing as multiplying by minutes over gallons. Anything can just be written as over 1. So gallons over 1 times minutes over gallon. The gallons will cancel out, and we just be left with minutes. So dividing these values the way we've set it up, we will get minutes for the units, and that's exactly what we want. We need a time measurement out. So that was a side note just on units. Hopefully you understood that. Okay, so 2400 divided by 5 is going to give us a number. And then we need to change that number into hours. So if I divide this by 5, I should get 480, and that's minutes. But notice that all of our answer choices here are in hours, not minutes. So how do we change minutes to hours? Well, we need to take this minute value, and we know how many minutes are in an hour. 60. There are 60 minutes in every hour. So we take this 480 and divide by 60, and that'll tell us how many total hours we have. And we know 8 times 6 is 48, so 6 goes into 48 8 times. We could get rid of the zeros to simplify it. So how many hours are in 480 minutes? Well, 48 divided by 6. This is hours now. 48 divided by 6 is 8 hours. So our solution should be letter choice C. And there we have it. So we can use addition, subtraction, multiplication, and division properties to solve one-step equations with real-world context or just using the variables themselves. So hopefully we understand that and we can tackle this work as we go forward.